All right, now we're going to get a little bit deeper into partitions. So we're going to kind of scratch the surface before. We're going to get a little bit more depth here. And you'll notice that as a common theme throughout this course, I'm going to be revisiting things you learned in previous courses, but then we're going to kind of go a little bit deeper than maybe you've gone in the previous course. So things will seem to be, they'll seem familiar, and then we'll kind of get a little bit deeper than perhaps where you were before. So partitions and file systems. We divide our file space into partitions. Remember, the file space is that logical view of our file system that I was talking about in the previous deck. Each partition contains independent file space, right? So each partition is its own independent file space or hierarchy of files. So this lets us manage a partition without having to impact other partitions, right? So each partition can have you can mount it separately, so you can unmount it and do things with it without affecting other partitions. You can encrypt it differently than the other ones. Maybe some partitions need to be encrypted and others don't. Encryption obviously adds a little bit of overhead. You can have quotas that are different in different partitions, so you can basically manage them independently. So it does give us some more granular tools in managing those file systems. Windows by default has a single partition, right? The C drive. So it's a little bit different in Windows. You can create additional partitions in Windows though. So you can have a D drive, an E drive, an F drive. So those are the partitions you'll see in Windows. It'll literally be the drive letters, right? In Linux, it's a little more complicated because they don't really necessarily align to drive letters. They align to those directory names that we see. So root is usually a partition, but root boot could be a different partition. Root var could be a different partition, and so forth. So it's not as clear cut as it is in Windows. All right, so there's some risks with partitioning. When you are physically dividing the disk into their own regions, if one is too small and you want to repartition it, if you don't, in order to repartition, so if let's say you have a disk that's a finite size, it's 100 gigabytes, for example, one partition is 50, the other is 50. If you want to make the first 50 175, you got to take 25 gigs off the other one. Well, if there's files sitting there, when you take away that 25 to put them on the other partition, that could be a problem, right? You're destroying those files in that file system and corrupting the file system. So it can get risky. There are some workarounds for that. One of them is using LVM, or a logical volume manager. This is so that you can create partitions of arbitrary sizes, and then the logical volume manager will allow you to shift those sizes, and it makes sure that you're not affecting the actual physical files when you do that. As long as the storage space is available, it'll let you change the partition. You always run a risk when you do that with other mechanisms. So in Linux, our hard disks are separated devices with names like SDA or SDB, right? So you go in that dev folder, your first solid state disk would be SDA, the second physical disk would be SDB, and so forth and so on. And then within those, you'll find your partitions like SDA1, SDA2, and so forth. So you'll see the actual partitions labeled that way. So the first partition is SDA1, the second partition is SDA2, and so forth. And if you have another disk, the first partition on SDAB will be SDA or SDB1, the second one will be SDB2, right? And so forth. And you can view those partitions, how those partitions are automatically being mounted is going to be in Etsy FS tab, although that's changing in some distros. But you can look in FS tab and it'll tell you, how those different partitions are going to be mounted. So here's an example that our author had from the textbook, where the author shows us how their partitions are mounted, and you can see the partition numbers here, right? So his physical hard drive is SDA, and it looks like it has 6 partitions, right? So the 6 partitions on that are not 6. 1, 2, 3, 4, 5. There's 5 partitions. It looks like he skipped one here, right? One of those is the root, then he's got a different partition for home, and then swap is a swap partition, and you can see the file system in that third column there, right? Now proc is special. That is actually a virtual partition. It's in memory, right? So it's not a part of the physical disk. CD-ROM is the CD-ROM drive that gets mounted. Notice that it has different operations, so it's read-only, whereas all the other ones are default. So default is read-write, it's everything, whereas that CD-ROM is read-only. And this one all the way down here in the bottom, it looks like a remote. So that's a remote file. So he's mounting a remote file system there using NFS. We'll learn more about NFS later in the course. We'll come back to that. But that's read-write and synchronous, so a little bit different. But that's basically what a typical FS tab might look like. So the mount options specify how the partition is going to be treated, and the default is a common entry. So 3 of the partitions that you saw there are a little bit different, like proc, tempfs, and so forth. So I already talked about all this in the previous slide. So we created the partitions at the time that we install Linux. You can just take the defaults when you install it. Now in the cloud, we very rarely install Linux. We just use whatever the cloud provider gives us in their image. However, if you wanted to, you could create your own Linux VM, upload it to the cloud. You can convert it and upload it to the cloud provider. There's different mechanisms to do that depending on whether you're using Azure or Amazon or Google. But in any event, if you install it yourself, you can do the partitioning at the time of the install or use the defaults. But again, in our case, they're being sort of thrust upon us by the cloud provider. But you know, a typical default partitioning is the root is a partition, boot is a partition, home is a partition, and swap is a partition. You don't necessarily have to do that though. So boot and home could be all in the same partition as root if you wanted to, but swap does always have to be its own partition. var could also be its own partition, doesn't necessarily have to be. So there's an example of, you know, some guidelines around creating these partitions. These are the minimum size, recommended size guidelines. I think most of us go much larger than that, right? But this is the minimal installation for Red Hat as an example for these partitions. But like I said, in many cases, we combine the root, home, and boot and var. They'll all be in the same partition, and then swap would be its own partition. At least that's how it is in the VMs that we spin up with Google, right? So when creating partitions, we specify their size. And once established, the size can be adjusted through repartitioning. But as I mentioned before, that can be a little bit risky because in order to change that partition size, you have to have space to take from. Now, if you have unpartitioned space on the drive, it becomes a lot less risky because you're taking space that you know isn't being used and you're sizing into that. However, if you're encroaching on another partition, if you're repartitioning one partition to make it smaller to then free up space to use that space for another partition, that's what can be risky. Generally, if you're going to do this, you want to make sure you back up the entire file system before you attempt to repartition, because there's always that chance that you're going to brick the entire drive when you do this. So when you resize the partition, you can use resize part to specify the partition and its new size. So it's just a utility that we can use. It's going to basically force you to go and, if there's no space available, it'll force you to go and steal from another partition first before it'll allow you to use that space. These utilities have certainly gotten a lot better. It's a lot less risky now than it used to be with a lot of these utilities. But certainly, like I said, there's always that risk. And to mitigate that risk, one option is to use LVM. So LVM is basically partitioning in software, right? So it's software that has one big partition that it then virtually partitions on your behalf. Now, LVM, because it's a software-based solution, it's going to be a little less efficient because it has to be involved in every disk operation, right? So you have that extra layer sitting on top of whatever you're doing. That's that extra abstraction of that partition. So sometimes it's a little more efficient to not use LVM, but you can also have a hybrid approach where you still have the traditional, boot, for example, partition and var or something like that, and then everything else is LVM. Now, I will say that with cloud computing, this is quickly becoming a little less relevant using LVM. One reason is because when we build a VM in the cloud, it's typically they're only going to give us like 10 or 20 gigabytes. You're not going to allocate 500 gigs to your machine. If you need storage, because your VM's already in the cloud, you're probably going to use object storage or elastic storage or something like that that you're going to mount separately. So this is really quickly becoming obsolete. And by the way, that object storage, you don't have to worry about partitioning when you're using object storage, right? That whole concept goes away, and it's all managed by that storage platform, and you're only paying for the portion of the storage you're actually using. If you allocate a 500 gig drive to a virtual machine, because you have a 500 gig drive, you're paying for that entire 500 gigs whether you use it or not. Whereas with object storage, you're only paying for what you actually need. You don't have to allocate all that space and then grow into it. It's growing with you instead, right? So it's a little bit more efficient. So that whole paradigm is changing because of cloud computing. So LVM defines a physical volume as a collection of storage space. And again, I don't want to spend a whole lot of time talking about LVM because, as I said, it's quickly becoming irrelevant with cloud computing. I think you would be hard pressed to find implementations of Linux these days that are not being deployed in the cloud, right? And even if they're not in the cloud, they're probably virtualized in your own data center. So you have your own private cloud. It's using similar technologies. So again, a lot of this is starting to go away. We're not really deploying physical servers that much anymore. They're usually VM farms. Now those VM farm servers are physical, right? But they're usually wholly managed by that VM software. So we don't really have to worry so much about that. And it's actually a whole nother subspecialty. Maybe one day we'll have classes on how to manage virtualization and build clouding and computing environments and so forth. But these are basically all the utilities that are used by LVM. So it's just a list of, this is from your textbooks. There's a chart of all these different utilities and how they're used with LVM. So if you, after you issue the fdisk, so fdisk is the tool we use to partition, right? So we use fdisk to create our partitions, but that's not the whole process. I talked about this in the previous slide deck, that once you create a partition, you also have to create your file system with the mkfs command. And typically you'll use the mkfs command to make some file system like ext or xfs or one of the other many file systems you saw on that list in the previous slide deck. And there are different mkfs utilities for various file systems. So you would have to decide which file system you're going to use and run that command to make that file system. And again, we're going to play with this a little bit in our lab environment. I'm going to show you how to do this. We're going to allocate a disk, we're going to mount it, we're going to partition it, and then we're going to make a file system on it and then use it.